In this lesson, you will learn about using authentication on the firewall policies of FortiGate. In this lesson, you will learn about the topics shown on this slide. FortiGate supports multiple methods of firewall authentication: local password authentication, server-based password authentication, also called remote password authentication, two-factor authentication. This is a system of authentication that is enabled on top of an existing method. It cannot be enabled without first configuring one of the other methods. It requires something you know, such as a password, and something you have, such as a token or certificate. During this lesson, you will learn about each method of firewall authentication in detail. Tokens use a specific algorithm to generate an OTP. The algorithm consists of a seed, a unique randomly generated number. Traditional user authentication requires your username plus something you know, such as a password. The weakness with this traditional method of Tokens use a specific algorithm to generate an OTP. The algorithm consists of a seed, a unique randomly generated number that does not change. Traditional user authentication requires your username plus something you know, such as a password. The weakness with this traditional method of authentication is that if someone obtains your username, they need only your password to compromise your account. Furthermore, since people tend to use the same password across multiple accounts, some sites with more security vulnerabilities than others, accounts are vulnerable to attack regardless of password strength. Two-factor authentication, on the other hand, requires something you know, such as a password, and something you have, such as a token or certificate. Because this method places less importance on, often vulnerable passwords, it makes compromising the account more complex for an attacker. You can use two-factor authentication on FortiGate with both user and administrator accounts. The user, or user group to which the user belongs, is added to a firewall policy in order to authenticate. Note that you cannot use two-factor authentication with explicit proxies. You can use one-time passwords, OTPs, as your second factor. OTPs are more secure than static passwords because the passcode changes at regular intervals and is valid for only a short amount of time. Once you use the OTP, you can't use it again. So even if it is intercepted, it is useless. FortiGate can deliver OTPs through tokens such as FortiToken 200 hardware token and FortiToken Mobile software token, as well as through email or SMS. To deliver an OTP over email or SMS, the user account must contain user contact information. FortiTokens and OTPs delivered through email and SMS are time-based. FortiTokens, for example, generate a new 6-digit password every 60 seconds by default. An NTP server is highly recommended to ensure the OTPs remain in sync. FortiToken Mobile Push allows users to accept the authorization request from their FortiToken mobile app without the need to enter an additional code. Tokens use a specific algorithm to generate an OTP. The algorithm consists of a seed, a unique randomly generated number that does not change over time. The time, obtained from an accurate internal clock. Both seed and time go through an algorithm that generates an OTP, or passcode, on the token. The passcode has a short lifespan, usually measured in seconds. 60 seconds for FortiToken 200, possibly more or less for other RSA key generators. Once the lifespan ends, a new passcode generates. When using two-factor authentication using a token, The user must first log in with a static password followed by the passcode generated by the token. A validation server, FortiGate, receives the user's credentials and validates the static password first. The validation server then proceeds to validate the passcode. It does so by regenerating the same passcode using the seed and system time, which is synchronized with the one on the token, and comparing it with the one received from the user. If the static password is valid and the OTP matches, the user is successfully authenticated. Again, both the token and the validation server must use the same seed and have synchronized system clocks. As such, it is crucial that you configure the date and time correctly on FortiGate or link it to an NTP server, which is recommended. You can add a FortiToken 200 or FortiToken Mobile to FortiGate on the FortiTokens page. A hard token has a serial number that provides FortiGate with details on the initial seed value. If you have several hard tokens to add, you can import a text file where one serial number is listed per line. A soft token requires an activation code. Note that each FortiGate and FortiGate VM provides 2 free FortiToken mobile activations. You must purchase any additional tokens from Fortinet. You cannot register the same FortiToken on more than one FortiGate. If you want to use the same FortiToken for authentication on multiple FortiGate devices, you must use a central validation server such as FortiAuthenticator. In that case, FortiTokens are registered and assigned to users on FortiAuthenticator, and FortiGate uses FortiAuthenticator as its validation server. After you have registered the FortiToken devices with FortiGate, you can assign them to users to use as their second-factor authentication method. To assign a token, edit or create the user account, and select Enable Two-Factor Authentication. On the token drop-down list, select the registered token you want to assign. All the authentication methods you've learned about, local password authentication, good job! You now understand the basics of firewall authentication. Now you will learn about remote authentication servers. Test. You can configure FortiGate to point to a Radius server for server-based password authentication through the Radius Servers page. The primary server IP name setting is the IP address or FQDN of the Radius server. The primary server secret setting is the secret that was set up on the Radius server in order to allow remote queries from this client. Backup servers with separate secrets can be defined in case the primary server fails. Note that FortiGate must be listed on the Radius server as a client of that Radius server, or else the server will not reply to queries done by FortiGate. The authentication method setting refers to the authentication protocol that the Radius server supports. Options include CHAP, PAP, MS-CHAP, and MS-CHAP2. If you select Default, FortiGate will use PAP, MS-CHAP2, and CHAP in that order. Unlike LDAP configurations, the Test Connectivity button used in the example shown on this slide can test actual user credentials, but like LDAP, you can also test this using the CLI. The Include in Every User Group option adds the Radius server and all users that can authenticate against it to every user group created on FortiGate, so you should enable this option only in very specific scenarios. For example, when only administrators can authenticate against the Radius server and policies are ordered from least restrictive to most restrictive. Testing Radius is much the same as testing LDAP. Use the Diagnose Test Auth Server command on the CLI to test whether a user's credentials can successfully authenticate. Again, you should do this to ensure authentication is successful before implementing it on any of your firewall policies. Like LDAP, it reports success, failure, and group membership details depending on the server's response. Deeper troubleshooting usually requires Radius server access. Note that Fortinet has a vendor-specific attributes VSA dictionary to identify the Fortinet proprietary radius attributes. This capability allows you to extend the basic functionality of radius. You can obtain the Fortinet VSA dictionary from the Fortinet knowledge base, kb.fortinet.com. Radius is much different from LDAP because there is no directory tree structure to consider. Radius is a standard protocol that provides authentication, authorization, and accounting AAA services. When a user is authenticating, the client, FortiGate, sends an access request packet to the Radius server. The reply from the server is one of the following: access accept, which means that the user credentials are okay; access reject, which means that the credentials are wrong; access challenge, which means that the server is requesting a secondary password ID, token, or certificate. This is typically the reply from the server when using two-factor authentication. Not all Radius clients support the Radius challenge method. Lightweight Directory Access Protocol, LDAP, is an application protocol used for accessing and maintaining distributed directory information services. The LDAP protocol is used. Lightweight Directory Access Protocol, LDAP, is an application protocol used for accessing and maintaining distributed directory information services. The LDAP protocol is used to maintain authentication data that may include departments, people, groups of people, passwords, email addresses, and printers. LDAP consists of a data representation scheme, a set of defined operations, and a request and response network. The LDAP protocol includes a number of operations that a client can request, such as search, compare, and add or delete an entry. Binding is the operation in which the LDAP server authenticates the user. If the user is successfully authenticated, binding allows the user access to the LDAP server based on that user's permissions. The root of the LDAP directory tree represents the Good job! You now understand the basics of remote authentication servers. Now you will learn about user groups. Guest user groups are different from firewall user groups because they contain exclusively temporary guest user accounts, the whole account, not just a password. Guest user groups are most commonly used in wireless networks. Guest accounts expire after a predetermined amount of time. Administrators can manually create guest accounts or create many guest accounts at once using randomly generated user IDs and passwords. This reduces administrator workload for large events. Once created, you can add accounts to the guest user group and associate the group with a firewall policy. You can create guest management administrators that have access only to create and manage guest user accounts. Guest user groups are different from firewall user groups because they contain exclusively temporary guest user accounts, the whole account, not just a password. Guest user groups are most commonly used in wireless networks. Guest accounts expire after a predetermined amount of time. Administrators can manually create guest accounts or create many guest accounts at once using randomly generated user IDs and passwords. This reduces administrator workload for large events. Once created, you can add accounts to the guest user group and associate the group with a firewall policy. You can create guest management administrators that have access only to create and manage guest user accounts. Good job! You now understand the basics of user groups. Now you will learn about using firewall policies for authentication. In the example shown on this slide, assuming active authentication is used, any initial traffic from local subnet will not match policy sequence 1, full access. Policy sequence 1 looks for both IP and user group information, local subnet and HR group respectively, and since the user is not yet authenticated, the user group aspect of the traffic does not match. Since the policy match is not complete, FortiGate continues its search down the sequence list to see if there is a complete match. Next, FortiGate evaluates policy sequence 2 to see if the traffic matches. It matches all criteria, so traffic is allowed with no need to authenticate. When you use only active authentication, if all possible policies that could match the source IP have authentication enabled, then the user will receive a login prompt, assuming they use an acceptable login protocol. In other words, if policy sequence 2 also had authentication enabled, the users would receive login prompts. If you use passive authentication and it can successfully obtain user details, then traffic from local subnet with users that belong to HR group will apply to policy sequence 1, even though policy sequence 2 does not have authentication enabled. If you use both active and passive authentication, and FortiGate can identify a user's credentials through passive authentication, the user never receives a login prompt regardless of the order of any firewall policies. This is because there is no need for FortiGate to prompt the user for login credentials when it can identify who the user is passively. When you combine active and passive authentication methods, active authentication is intended to be used as a backup, to be used only when passive authentication fails. As well as the DNS service, the firewall policy must specify A firewall policy also checks the service in order to transport the named protocols or group of protocols. No service, with the exception of DNS, is allowed through the firewall policy before successful user authentication. DNS is usually used by HTTP so that people can use domain names for websites instead of their IP address. DNS is allowed because it is a base protocol and will most likely be required to initially see proper authentication protocol traffic. Hostname resolution is almost always a requirement for any protocol. However, the DNS service must still be defined in the policy as allowed in order for it to pass. In the example shown on this slide, policy sequence 1, full access, allows users to use external DNS servers in order to resolve host names before successful authentication. DNS is also allowed if authentication is unsuccessful because users need to be able to try to authenticate again. Any service that includes DNS would function the same way, like the default all service. HTTP service is TCP port 80 and does not include DNS UDP port 53. As well as the DNS service, the firewall policy must specify the allowed protocols such as HTTP, HTTPS, FTP, and Telnet. If the firewall policy that has authentication enabled does not allow at least one of the supported protocols used for obtaining user credentials, the user will not be able to authenticate. Protocols are required for all authentication methods that use active authentication, local password authentication, server-based password authentication, and two-factor authentication. Active authentication prompts the user for user credentials based on the following: the protocol of the traffic, the firewall policy. Passive authentication, on the other hand, determines the user identity behind the scenes and does not require any specific services to be allowed within the policy. Good job! You now understand how to use firewall policies for authentication. Now you will learn about authenticating through Captive Portal. If you want all users connecting to the network to be prompted for their login credentials, active authentication, you can enable Captive Portal. Captive Portal is a convenient way to authenticate web users on wired or Wi-Fi networks through an HTML form that requests a username and password. You can host a Captive Portal on FortiGate or an external authentication server such as FortiAuthenticator. You can configure a firewall policy to suppress Captive Portal for specific addresses or services. This is useful for devices that are unable to actively authenticate, such as printers and fax machines, but still need to be allowed by the firewall policy. When suppressed, traffic that matches the source or destination is not presented with the Captive Portal login page. There are two ways you can bypass Captive Portal: through a security exemption list in the GUI or the CLI under Config User Security Exempt List, through the firewall policy. In the CLI, edit the policy and enter the command Set Captive Portal Exempt Enable. All traffic matching this policy is now exempt from having to authenticate through the Captive Portal. If you want to enable a Terms of Service disclaimer to be used An Authentication Timeout is useful for security purposes. It minimizes the risk of someone using the IP of the legitimate authenticated user. It also ensures users do not authenticate and then stay in memory indefinitely. If users stayed in memory forever, it would eventually lead to memory exhaustion. There are three options for timeout behavior. Idle looks at the packets from the host IP. If there are no packets generated by the host device in the configured time frame, then the user is logged out. Hard. Time is an absolute value. Regardless of the user's behavior, the timer starts as soon as the user authenticates and expires after the configured value. New session. Even if traffic is being generated on existing communications channels, the authentication expires if no new sessions are created through the firewall from the host device within the configured timeout value. Choose the type of timeout that best suits the authentication needs of your environment. Good job! You now understand authenticating through captive portals. Now you will learn about monitoring and troubleshooting. In the web-based manager, a good tool for troubleshooting is the Bytes column on the Security Policy page, which you open by clicking Policy and Objects, Firewall Policy. This column displays the number of bytes that have passed through this policy. This is valuable information to have when you are troubleshooting. When you are testing your configuration, end-to-end connectivity, user authentication, and policy use, watching the byte count for an increase can help with troubleshooting. An increase indicates if the policy in question is seeing any traffic, which is useful information if you expect a user to require authentication but they are never prompted. Use the following CLI commands to gather more information about users and user authentication attempts to help troubleshoot failed authentication attempts. Diagnose Firewall Auth List shows authenticated users and their IP address. Diagnose Firewall Auth Clear clears all authorized users from the current list. This is useful when you need to force users to re-authenticate after system or group changes. However, this command can easily result in many users having to re-authenticate, so use it carefully. Diagnose Debug Application FNBAMD-1. Use this command to troubleshoot active authentication. You must use it in conjunction with Diagnose Debug Enable. Diagnose Test Auth Server Radius Direct, IP, Port, Secret. Tests pre-shared key between FortiGate and the Radius server. Diagnose Test Auth Server LDAP, server name, username, password. Tests LDAP authentication for the specified user account. Congratulations, you have completed this lesson. Now you will review the objectives that you covered in this lesson. This slide shows the objectives that you covered in this lesson. By mastering the objectives covered in this lesson, you learned how to use authentication on the firewall policies of FortiGate.